This is Network Security, Firewalls, and VPNs, Lesson 8, corresponding to Chapter 8, Firewall Deployment Considerations, Part 1. Our learning objective is to assess firewall design strategies. The key concepts of this chapter are the purpose of written firewall policies, how reverse proxy and port forwarding enhance internal network security, the use of protected DMZs and publicly facing bastion hosts for providing security, and strategies for internet and private network separation. What should you allow and what should you block? You need to perform a complete inventory. The inventory is of all your needed or desired communications. It should include every transaction between internal systems as well as any interaction with external systems, and should also include the protocol in use, the port or ports in use, and the likely source and destination addresses of each particular type of communication. Here we have an example of a partial list of communications occurring on a network. From the inventory, you want to block from crossing the network border all communications that should only be internal. The default deny rule will block these communications from doing so. But when a port is in common, it's possible that an allow rule for a valid external communication would also allow external entities access to an internal only communication. An example of this is in the SMTP mail protocol operating over port 25 in this example. By defining an allow exception rule, you could create a loophole that threatens the internal communication on the very same port. You want to reduce this risk by using a very specific rule or adding an additional deny exception. A very specific rule in this example would allow external communication over port 25 only if it originated from the internal email server at 192.168.42.115. If any other internal host attempted an external SMTP communication on port 25, it would be denied. And here we see TCP, the port 25 SMTP, the source, and the destination is the external email server. What to block? You need to block all Internet Control Message Protocol ICMP traffic originating from the Internet. Any traffic directed specifically to the firewall. Any traffic to known closed ports. Any traffic to known ports of known malware, such as 31337 used by back orifice. You should block Inbound Transmission Control Protocol, TCP53, to block external DNS zone transfer requests. Inbound User Datagram Protocol, UDP, port 53, to block external DNS user queries. Any traffic from IP addresses on a blacklist, and any traffic from internal IP addresses that are not assigned. We'll look at some common security strategies for firewall deployments. Security through obscurity, least privilege, simplicity, defense in depth, and diversity of defense on this slide. Security through obscurity is the idea of gaining protection by using abnormal configurations. This is both a positive security action and a poor one. For example, just modifying a basic configuration setting doesn't provide security. If servers typically operating on one port that's reconfigured to use a different port is not good security. A common mistaken example of security through obscurity in the non-technical world is hiding your front door key under a rock in a flower bed, or perhaps hiding your financial records among the audio files on your MP3 player. Least privilege is one of the basic concepts of network security. Users should have the minimum level of access to resources needed to complete assigned tasks. The drawback to this is the need to control every user's access individually. You can group users into collections of similar job functions or security levels, granting permissions to the group as a whole. Simplicity makes it easier to understand the security, manage it, and troubleshoot it. The more complex a solution, the more room there is for mistakes, bugs, flaws, or oversights to creep in undetected by security administrators. Defense in depth. This is multiple layers or barriers to access secured resources. One aspect is to deploy multiple subnets in series to separate private resources from public. Diversity of defense. This is similar to defense in depth, but that each of the layers uses a different security mechanism. Multiple firewalls is defense in depth, but not diversity of defense. Adding tools such as IDS, antivirus, strong authentication, VPNs, and other items like that leads to more diversity. Here we see choke point, the weakest link, failsafe, and force universal participation. A choke point forces all traffic, communications, and activities through a single pathway or channel. This pathway can be used to control bandwidth consumption, filter content, provide authentication services, or enforce authorization. As a security mechanism, it only has value if it is hard to bypass or avoid the bottleneck itself. The weakest link is any security infrastructure is only as strong as its weakest component. This stance is an ongoing process of locating the least secure element of an infrastructure and securing it. Failsafe. This is not just about using failsafe security devices, but about designing the overall infrastructure with failsafe as a core focus. And force universal participation. For security to be effective, everyone must work within the limitation established by your organization's written security policy. Everyone, from the lowest ranked worker to the CEO and every senior executive, must follow the same security rules. Examples of users purposely avoiding security include choosing poor passwords, sharing accounts with others, using personal computer equipment on the company local area network, using personal removable media on company equipment, and installing unapproved software. Here we see a slide showing separating public from private resources. An aspect of defense in depth is to deploy multiple subnets in series to separate private resources from the public. This is known as n-tiered deployment. N represents the number of subnets under private control. So here you see a firewall separating the DMZ switch, which has attached to it the web server and the email server, and then another firewall separating the database subnet with a switch and its database server, and then yet another firewall separating the private local area network from the database subnet and various different devices attached to that switch behind that particular firewall. And so this concludes part 1 of chapter 8.